Hello everyone. So this is a question from NEET 2025. Identify the suitable reagent for the following conversion. So as we can see, this is an ester and this is an aldehyde, and there are four options given to us: sodium borohydride, hydrogen in palladium, lithium aluminium hydride, dibalh H. Okay, so which of these are going to do this conversion? The chapters involved is aldehydes, ketones, and carboxylic acids and alcohols. So it will be better if we look at these reagents one by one and what can they do, and then we can analyze which of them can actually do this conversion. Okay, so when we look into the reagents, the first reagent that we see is A. So A is sodium borohydride, that is NaBH4. Sodium borohydride. So this guy, it is used for the preparation of alcohols. So alcohols are prepared by treating aldehyde and ketones with sodium borohydride. So this is a very famous reducing agent. So we have aldehydes oblique ketones. They are used to convert into alcohols by using NaBH4. Okay, this is the use of this guy. So whenever you have an aldehyde or a ketone and you want an alcohol, obviously if you have an aldehyde you will get a 1 degree alcohol, and if you have a ketone you will get a 2 degree alcohol. So depending upon the requirement, the reagent that is to be used is sodium borohydride. Okay, for example, if you have a ketone that is RC double bond O R dash, and if you want to convert it into a secondary alcohol, that is to RCHOH R dash, then NaBH4 can be used for this conversion. Then we have the second reagent which is given to us in the option is hydrogen over the catalyst palladium, and it is supported on barium sulfate. Okay, so the second reagent is H2PD on BaSO4. Okay, so this is used to convert acyl chloride or acid chlorides, that is RCOCl. Okay, acyl chloride, they are also known as acid chloride. The formula is RC double bond OCl. So whenever you want to convert these guys into aldehyde, RCHO, whenever you want to do this conversion, so what we do is we do hydrogenation. Okay, hydrogenation is reaction of hydrogen. We add hydrogen to this acid chloride over the catalyst palladium. The catalyst is palladium, which is supported over BaSO4. Okay, and this is a very famous name reaction which is known as Rosenmund reduction. Okay, so this is Rosenmund reduction. So hydrogenation, then supported over palladium on BaSO4. Okay, so that is the use of the second reagent. The third reagent is lithium aluminium hydride. Okay, which is another famous reducing agent. So the third one is LiAlH4, which is another very strong reducing agent. So this guy has two uses. It is used for two conversions. So we can use this guy to convert alcohols. So we can make alcohols by treating aldehyde and ketones with lithium aluminium hydride. Okay, so alcohols prepared by treating aldehyde and ketones with LiAlH4. Okay, so if you have an aldehyde, if you use LiAlH4, you will get 1 degree alcohol. If you have a ketone, if you use LiAlH4, you will get a 2 degree alcohol. Okay, and this is very similar to sodium borohydride, that is NaBH4. It has one more use. The other use of this reagent is carboxylic acids are reduced to 1 degree alcohols by LiAlH4. Okay, carboxylic acids reduced to 1-degree alcohols or primary alcohols by LiAlH4. Okay, for example, if you have a carboxylic acid RCOOH, if you use LiAlH4, then we'll be getting RCH2OH. Okay, and we cannot use sodium borohydride for this. Okay, that's an important thing, that NaBH4 cannot be used for this. So remember this point. Whenever you have to convert, a carboxylic acid to a primary alcohol, always LiAlH4 has to be used. And the next and the last reagent that is given to us is diisobutyl aluminum hydride, which is also known as DiBALH. Okay, so the last reagent is diisobutyl aluminum hydride. Okay, and the structure of this, so this is the acronym for DiBALH, and the structure of this guy is, aluminum has valency 3, so it is a hydride, so one is for hydrogen, the other two are diisobutyl group will be there. So diisobutyl groups are obviously CH2, CH, CH3, CH3. Okay, and a similar group will be attached on this valency of aluminum also, so we will have CH2, CH, CH3, CH3. So you can see this is the structure of your DiBALH, and this reagent is used whenever you have to convert esters to aldehydes. Okay, this is the use of this particular reagent. For example, if you have this ester, that is CH3, CH2, 9, C double bond O, O, C2H5. So for example, you have this ester. If you use DiBALH and water, so what will happen? This will become an aldehyde. Okay, so instead of this group, you will be getting an H over there. So the answer will be CH3, CH2, 9, C double bond O, H. We'll be getting this aldehyde. Okay, now in the given question, now let's come back to the question, because now we know all the 4 reagents and where are they used. In the given question, can you see this is an ester and can you see this is an aldehyde? So whenever you have to convert an ester to an aldehyde, the reagent that we have to use is DiBALH or diisobutyl aluminum hydride and water. Okay, so therefore this option is the correct option. So D will be the correct answer. Okay, thank you.